Hi everyone, in today's lesson we'll be looking at the trigonometric ratios, which is relating the sides with the angles in a right angle triangle. So in a right angle triangle, we know opposite the right angle is our hypotenuse. Directly opposite our theta, okay, which is the Greek letter, is the opposite side. And the side that is right beside the theta and a 90-degree angle is the adjacent side. Now we've got three trigonometric ratios that we need to know. These are called the sine ratio, cosine ratio, and tangent ratio. And the way we write this is we use the first three letters of each of these words, and we put theta next to it, and that becomes the trig ratio. So this is sine ratio, cosine ratio, and tangent ratio, okay, or sine cos tan. Now the sine ratio is opposite over hypotenuse, okay? So this relates this side here, opposite theta, over the longer side. Cosine theta, the next one, is adjacent over hypotenuse. So that's this side here over this side here. Tangent ratio is opposite of adjacent, which is this one, over the adjacent side there. So we have a mnemonic that we use to remember all this by using the first letter of cosine, adjacent, sine, whatever. And from the ones I've circled, we can see that we get SOHCAHTOA. So SOHCAHTOA allows you to remember all these ratios, and that's what you use for every single question. Now, hang on. When we look at exercise 8.02, for each marked angle, find the sine, cosine, and tangent ratios. So for question A, if I was to find out what the sine ratio is, using SOHCAHTOA, if I write up here, well, the sine ratio relates opposite and hypotenuse. Okay, I'm just going to write that here for you. Now, let's label these. The longer side of the triangle is what we call the hypotenuse. Directly opposite the theta is our opposite side. And our adjacent side is the remaining side, which is right beside the theta and 90-degree angle. So if sine theta equals to opposite over hypotenuse, opposite is 55, whereas the hypotenuse is 73. So we're going to write down here 55 over 73. Now, what if I found out what the cosine ratio is? And the cosine ratio is adjacent of hypotenuse. Okay, so that means cosine theta, the cosine of this angle, is going to be the adjacent side, which is 48, over the hypotenuse of 73. Lastly, if I have tan theta, or tangent of theta, that's opposite over adjacent. And you can see that by sounding out TOA. So the opposite side in this case is 55, whereas the adjacent side is 48. Okay, and now we've got our three trig ratios for the first triangle. Now, if I move on to question B, if I find out sine theta, in this case, well, sine theta is opposite over hypotenuse, so let's identify those. Our longest side is capital H, okay, represented by this lowercase f. Opposite theta is O, and our adjacent side is the one right beside the theta and 90-degree angle. So sine theta is opposite over hypotenuse, which I don't have to write all again. So opposite of a hypotenuse will be E over F. Now cosine theta, if we look at the mnemonic, cosine theta is adjacent over hypotenuse. So A over H. So that will be G over F. Whereas for the last one, tangent of theta, okay, is opposite over adjacent. So opposite's E, whereas adjacent is G. So write E over G. Now for question C. Now instead of using theta, we've now got an angle here that's unknown. So we'll just use the corner letter to denote that angle. So we'll say sine R, cosine R, and tan R. So let's just write out what these sides represent again. So the longest side opposite the 90-degree angle is our hypotenuse. The one that is right opposite the angle here is the opposite side, and the one adjacent to the 90-degree angle and the other angle is the adjacent side. So sine of r will be opposite over hypotenuse. So opposite is this side, which we'll use the corner letters for. That's st, okay, or you can write ts, over the hypotenuse, which in this case is rt, or tr. Cosine theta, in this case, if you look at the mnemonic, is adjacent over hypotenuse. So the adjacent side is rs, and we'll put that over rt, which is our hypotenuse. Our tangent ratio is opposite of adjacent. So opposite is st over adjacent, which is rs. Right, so that's question 1 done. Let's move on. Question 4. For each triangle below, find tan theta, cosine theta, and cos phi, and tan phi. Okay, this is another Greek letter. So, with part A, let's try and find out what tan theta is. So, if I just ignore the phi and just use theta to denote all my sides to do with hypotenuse, adjacent, and opposite, the hypotenuse is always going to be 25. That's always going to be the longer side. But opposite theta, okay, is going to be this length, which is going to be 24. And our adjacent side to both theta and just the 90-degree angle is the length of 7. Okay? So remember, tan of theta, in this case, is opposite over adjacent. So O over A is going to be 24 over 7. Now, if we're going to use exact same sides, okay, in relation to the theta, then cosine theta, okay, so SOHCAHTOA ka for cosine theta, is going to be adjacent over hypotenuse. So we have to look at number 7 and 25 as our adjacent side over hypotenuse. That will be 7 over 25. But then now we have cosine phi. Okay. Now what I'm going to do is, don't worry about the H, A, and O for now. We're going to restart that. But by looking at the right angle triangle again, our longer side is still 25. But if you now look at where opposite phi is, it's number 7. So we'll look at number 7 as our new opposite when I use this angle. But our last edge here is right beside the 90-degree angle and the phi. So we call that adjacent. So just by looking at the purple letters that we've used, cos phi, okay, I should write part 3 also. Cos phi is going to be adjacent over hypotenuse, as indicated by the mnemonic. So this will be 24 over 25. Okay, whereas for part 4, if I was to find tan of phi, then we have to look at opposite over adjacent. So opposite phi is 7, and the hypotenuse here is 25. Okay, there we go. Question B is very similar. So if I now use theta as my reference angle and label my hypotenuse, it would still be opposite the right angle, but opposite theta is the opposite, and beside theta and 90-degree angle is our adjacent side. So then if we use these 3 values now to find what tan theta is, well, tan theta is opposite of adjacent. Opposite in this case is u, adjacent is v, so we're going to say u over v. Then we can have a look at what cosine theta is. So cosine theta in this case is adjacent over hypotenuse, as indicated by ka. So that will be v over w. Then we have a look at what cos phi is. So because we're now using phi as our reference angle, the h here is still our hypotenuse, But then directly opposite the phi is now our new opposite, and right beside the phi and 90-degree angle is our adjacent side. So cos phi is going to be adjacent over hypotenuse, which in this case is u over w. Part 4, tangent of phi is going to be over a, or opposite of adjacent. So the opposite side to phi, as we can see here, is v. The adjacent side is u. That's v over u. Right, and that's it for the examples for question 4. Let's have a look at question 8. Sketch a right-angled triangle for each trigonometric ratio, then use Pythagoras' theorem to find the length of the unknown side and the other two trigonometric ratios for the same angle. So Pythagoras' theorem involves c squared equals to a squared plus b squared when we're finding the hypotenuse. But if we find out the shorter side, then a squared equals c squared minus b squared. Okay, so that relates to a triangle that has c, a, and b like that, where c is the hypotenuse. But let's have a look at what this ratio stands for. The tangent ratio, according to our mnemonic, Sakatawa, okay, if we have a look at the last bit, is over a. So what this represents is our opposite side over our adjacent side. So if we draw a triangle where angle A is here, okay, let's just say this is angle A, then this opposite edge is directly opposite A. So we're going to say this is 5. Whereas this number here is adjacent to angle A. So the one that's next to angle A and also next to the 90-degree angle is this edge, which we'll call 12. Which means we have something missing, which is our hypotenuse. And if we want to find that in a right-angled triangle, well, we have to use this formula. So we'll say this is, let's just say this is x, something we need to find, and x squared would equal to 5 squared plus 12 squared, if we use the Pythagoras theorem. X squared would then equal to 169, in which case we have to square root both sides to undo that square on top of the x, and that will cancel that out, so that you get an x left equals to the square root of 169, and typing that on my calculator gives me 13. So that means x is now 13 here. So what's left for me to do is to find out the other trig ratios of the same angle. So we found the length of the unknown side for now. We've done that, so we just got to do this. So at the moment we've got tan of A. That means we just got to find out what cos of A is and sine of A is. So cosine of A is adjacent over hypotenuse. Okay, well, the opposite side to A, in this case, is 5. The adjacent side to angle A and theta is 12, whereas the hypotenuse is 13. So if cosine theta is adjacent over hypotenuse, that means we're looking at A being 12 and hypotenuse being 13. Now sine of A is going to be the opposite to this angle, which is number 5, over h, which is the number 13. Okay, indicated by so. Okay, so again, this is 5, which is opposite, over the hypotenuse of 13.